I wanted to show you where do we get the value of maximum disconnection time. In sheets we've got the question of maximum disconnection time, and we've got two earthing systems in England. We've got TN, so this is BS7671, that's the 18th edition, that's table 41.1 maximum disconnection times, and we've got TN, and it could be TNCS or just a TNS system or TT system. The sun is coming back to Bristol and we are installing an EV charger today. Come with me, I show you what we are doing. We've got a Hypervolt, and this is the Model 3 tethered with 7 meters of cable. We're going to install it just here on the external wall. The cable run will be down, so what we have here is 6mm Ultra EV cable, and that will be coming down from the EV charger. Client asked if we could also tag along the other black cable. That is an internet cable. Shouldn't have any interference because our cable is shielded. We're going to clip it along. I've already had a go behind the bushes and managed to move the bins. My cable just stretching all the way down for now. We have that little obstacle to come around, and I thought just by drilling at an angle to find myself right in there would be the idea to do it. There's a sufficient room behind the gas meter. At that point we have to go quite low with the cable because of the internet and the TV data. Coming across, cutting the groove. I've already asked client to remove the paving slabs, so we will have to cut the groove within the bed of the tiles. Most likely one of these bad boys, that's the external Proteus fuse board with double pole RCB 40 amp main incomer and also an SPD. So this fella is a waterproof, so it will comfortably sit outside. Most likely we'll install it just on that side of the wall just to feed the cable maybe through the bottom, or we'll see. What do you think? An easy peasy? Well, definitely it's easy with the weather like that on our side. If the weather isn't on our side, nothing is easy. I might made a mistake. I've told Tom to be here at 8:30 instead of 8 o'clock, and I'm like, gosh, has Tom got a message or not? I really would like some help with just clipping the cable all the way along. My knees are not as good as they used to be. Anyway, come with me, let's have this. I think we're going to start. Firstly, we may start with the actual EV charger. Put it on the wall, terminate the cable so we know how much of the cable we need on that side, and then just backtrack all the way around into the location of the fuse board. Job is a good one, as they say. Let's crack on with the EV charger first. Come with me. Okie dokie. Do I need a kneeling pad? Maybe not for now, maybe for later. This charger battery, a 6mm bit. Small impact should be in my bag already. And some screws. These looks decent. Someone is trying their throttle. Anyway, cool. So here's our baby. We put this down. So as you see, I'm using the box, I'm moving the cardboard box to minimize any scratches that we might put onto the either plug, EV charger, whatever. Just want to keep it nice and clean for the client. It is that one, I believe so. Okay, that's coming off. There is one of these 8-pin plugs, which we don't need right now. We do need a bracket though, to put it on the wall first. Then we can hang our EV. Then we can start the rest of the connection. Fun. Right. I'd rather use my own wall plugs than whatever has been supplied by them. I know these wall plugs are really good, the Fisher ones. If you put them in, they're not coming out. That's the kind of thing we want. For this one, I might use like a pan head screws, like these fellas. Not all the way. Hey, Tom is with us. Good morning, Tom. I was worried you didn't get the message and I might be here. I think I've put 8:30. I was afraid I might need to pick up materials and be here quite late. Perfect. This is the moment we're just using these two elements to hook it on, and there should be a nut. Why am I not surprised? We need all the different Allen keys just to secure one thing. And by the way, I'm trialing this out. This is now second week as I have these set. Vera mechanical extended set of the screwdrivers. Well, kind of, I don't have to go in the van and pick up, but when I'm on the ladder, I usually used to have 2-3 screwdrivers, maybe 4 sometimes, and what I did like about it is the handle were different. And I think my speed in terms of like picking up the screwdriver and installing it was quicker because I didn't have to faff around with changing the handles. Yeah, anyway, I'm just have to take an extra time to install everything.
One eternity later.
That's there. We now need to drill the hole. And the hole is determined by the size of the cable and by the size of the gland. So this being 25 glands, it means that the hole I need to make in the EV, it's 25. It's determined by this. The trick, I'll put these in my pockets. The temperature of my body will warm them up. 25, 25, 25. There you are. 25. Beautiful. Yeah. On the underside of it, we've got like a central point right there. When you work with SWA cable, you have to earth the sheath on either side of the cable. What I'm actually deciding to do is, I'm actually quite tempted to put a compression gland on this end. That's not good enough, that's too small. And this is not the right one. That is for a conduit. I'll see if I actually have a compression gland. Okay, we are in the car. We are aiming just for these with maybe kind of a swish of some sort. So that's where we're aiming to strip the cable. This also would be a good time to put the shroud on it. The way I do it, push it. Knife, step change. I will continue pushing it down just to make sure the fitting is nice and snug. Now, flip it the other way around. Sometimes even put the cable on the inside. And yeah, that's a beautiful fit. Cool. And what we can put right now is just the bottom bits. I'll need the top one with the olive. Stay there. That one goes in here. Knife, always away from your body. I worked with the electrician who have done it the other way around, and well, he was holding to his fingers, I put it that way. Not a good experience, don't do it. Well, I'm so happy the winter will be finally over soon, because working with SWA in a cold weather, guess what, not the easiest thing. This is the moment we want to strip about 2 centimeters of the black PVC sheath to expose the armoring, just like that. Might twist that way nicely. I will do just a very... This is not even cutting, this is just scouring the cable around. So the first nut is to clamp on this olive inside and clamp onto these metal sheath. The second one is like an external grip from the bottom that it would just make this waterproof. Okay, shroud back in. So that side is done. What I might do is just clip it just below it with one there. We're using all-round banding. Is how many? 2, 4, 6. 6 of these. Tom, 25 might do. The outer diameter is about 20.5. So we should be okay with 25. Yeah, I know. Do not cut towards your body. Let me introduce you to the cables. Earth, neutral, live. This is the string in the middle that just only allows to fill the gap between all the cables and keep it the round shape. So that's not needed. And here is our data cable, which is beautifully shielded within. So plastic sheath first. Also, it has this aluminium screen. And each individual pair is also screened off. We will pick up, I'm feeling blue today. All the rest of it, I'm actually going to keep it. Just go and put a tape around these, because I don't need all the other 3 pairs. They are not required. Can't use a white tape because it's not in my bag. When I was telling you about this swish, I'm thinking about something like that. So it's just nice and easy to put the cables in or out if we have that little swish. Earth, neutral, live, that's the order. We know where to cut the cables. Yes, yes. Strip. Neutral in the middle. ENL, yep. Just shove it down here, just like that. That's where we are adjusting for a maximum load and demand calculation. Oh man, I can't remember which one it is, but... Client bought an EV charger and it came without the CT clamp and without this little green terminal. And I found it actually quite disgusting. How can you do that? Diagram for a CT clamp. Number 3 looks like number 3 is CT clamp 1, CT clamp 2. Okay, so the 3. So as you see, each pair has its own individual aluminium, and this doesn't matter. It's not polarity orientated which port it goes into. What I do is you can actually use your nails to strip the insulation on this bugger, slightly trim it, double it over and into the terminal, just like so. And I would highly recommend to give it a pull, just to pull it, just to see if they are sitting there nicely. This aluminium is not needed. I'm just gonna do this with it and in. So CT clamp connected. Get it out of my way. We're gonna keep this screwdriver. We're gonna keep all the other ones. At this point we'll have to leave it because we need to do some tests on the cable, like RCD tests, earth, impedance, and other very important tests. Here should be good. Kind of. Let's just check if the pan head screws are the right type for this. Oh yeah, beautiful actually. Pan head in my opinion are better because they got flat underside as opposed to this one, which is designed to go into the wood. I prefer this one because it clamps on plastic equally. And if you're using power tools, then you have to be careful because obviously it's one flick of a finger and the plastic box is broken. Firstly, drive them in a little bit at a time, making sure all the holes align nicely. Here they are. You know where to finish when there is a sudden change in the high pitch of the impact driver. Yeah. Apparently the new drivers, they've got this technology when they feel where the actual torque changes and they stop, and you can adjust it for 1% more or whatever. Fancy to get one of those? Maybe I will. That one is playing up on me. Okay, I'm not sure if I will be able to just put the cable on now, if it's not going to restrict me later by attaching the actual front cover. We'll do it so it's off the ground. Ah, Hypervolt. Cool. You stay. Firstly, we're going to open it up and see what's inside, just to make sure we're not going through any part of the existing cables that may be joined up to the SPD. That way round.
One eternity later.
Let's mount this bugger. The way I want it is here. Right there. Okay, we can spray into this one, spray into that one, spray into the top two. That's what I'm thinking. Twist. Good thing this is a one-hand operation. So, you know about risk in the job that we have. Tom is supplementing himself with something like that.
Wait a minute!
Actually, no. Tom just found these syringes in the bushes. You would never think someone would help themselves by dosing it. Go careful, Tom. Yeah, Tom just brought it to my attention. Like, this is the risk we're going through. Like, who would know that there will be lying syringes anywhere? Bloody hell. Makes you think, yeah? wanted to show you where do we get the value of maximum disconnection time. In sheets, we've got the question of maximum disconnection time, and we've got two earthing systems in England. We've got TN, so this is BS7671, that's the 18th edition, that's table 41.1, maximum disconnection times, and we've got TN, and it could be TNCS or just a TNS system or TT system. And we are working on the voltage between 120 and 230 volts. Our AC, so we've got two, AC and DC. This is a TN earthing system, and the disconnection times maximum is 0.4. Maximum permitted ZS cable for SWA. We are on the type B and we are on 40, so it's 1.09. So that's the maximum ZS value we are getting. And if we were to remove like a 20%, so it will be tabulated, because these are the maximum ones, so they are not being lowered by the rule of a thumb by 20%. It will be 20% less than what we have to also account for. By the book is 1.09. 1.09. Done. Thank you. You're doing 2-lead test, 0.13. Brilliant, and 1.74 the fault current. If you connect to the fuse board, the earth now, we will do a 3-lead test now. TNCS, type 2, number of phases 1, rating 100 amps, 6122. Happy days, supplied from mains. Do a ZS at the board, please. You've got a ZS at DB, and this is almost like a DB2. So we just want to confirm we don't have any other.
I haven't seen that on a form before.
Okay.
Normally it's like at the end of the circuit, isn't it?
Yeah, right at the bottom you've got added the DB details.
Right.
On Android, maybe somewhere else, and here is just asking the details of the
easy set.
Yeah,
right.
Yeah.
I don't think I filled that out for that last time.
We have to go back and edit. One of the first pages would cover that, but here is asking ZS at DB rather than ZE.
Yeah, it had all the other questions, but.
Okay, polarity is fine. There is no phase sequence, and Tom is just going to confirm the details of the ZS. You know, I didn't figure out with my tester how to do an auto test.
Oh man, what the?
I still have to press the button. So it's 0.15 and 1.58. Cool, thank you, Tom. Well done. Let's go and get a ZS test from the other end. If you get all the 3 crocodile clips, I'll energize this in a moment.
A few moments later.
Go for it, Tom! Okay, I think this was it. Okay, the charger's on, Tom is ready. Tom, if you just put this together.
Is that it?
Let me go and energize it. If you put this onto the C for charging, 32 ZS on your part. Low voltage. So it's green, we just have to wait for the charger to pick up some brains and do the self-test, check that this is all okay. It would be 3 low tests, and you've got the DC. So on the tester, what we have is, I show you that way, we need to set up the 3-lead low test, and hit right down below, we've got the actual DC symbol for DC RCD. Yeah, it does take a moment. There are no physical buttons on the charger anywhere here. And again, the charger has built-in delay. And the question is, if it is in that delay status, it will take some time before it actually allows it to charge.
It takes some minutes.
It takes some minutes.
Get going.
Okay. We are very impatient, yes. Well, actually, if you leave the tester, it will carry out the test for us, because it's on auto test.
Hopefully.
Yeah, ZS is an auto test. If the live comes in, let's put this to a test.